Hello students, today we will discuss the topics interference and diffraction. These two topics belongs to optics branch of physics. Optics means that physics which is related to light. Interference. In general definition, we can say that when two light waves from different coherent sources meets together, then the distribution of energy due to one wave is disturbed by the other. This modification in the distribution of light energy due to superposition of two light waves is known as interference of light. Or, in other words, we can say that the redistribution of energy is known as interference of light. For the occurrence of interference, it requires certain conditions to be satisfied. What are those? Condition first, the two sources should emit continuously waves of same wavelength or frequency. Second condition, the amplitudes of the two waves should be either or nearly equal. A good contrast between a maxima and minima can only be obtained if the amplitude of two waves are equal or nearly equal, or whatever the best possible. Requirement number 3, the two sources should be monochromatic. Of course, they should have the single wavelength. Requirement number 4, the two sources should be coherent one. Now, let us categorize the interference. There are two types of interference. One is constructive interference, one is destructive interference. When two light waves superimpose with each other in such a way that the crest of one wave falls on the crest of the second wave and trough of one wave falls on the trough of the second wave, then the resultant wave has larger amplitude and it is known as constructive interference. In the condition of interference, the observed pattern is bright. For constructive interference, there is a particular relation between the path difference and the wavelength, according to which the path difference should be equals to the integral multiple of the wavelength, where n is the 0, 1, 2 and 3 and so on. For destructive interference, the two light waves superimpose with each other in such a way that the crest of one wave coincides the trough of the second wave. Then the amplitude of resultant waves becomes 0 and the observed pattern becomes dark. This is known as destructive interference. As similar to constructive interference, there is also a particular relation between the wavelength and the path difference, according to which n plus 1 lambda by 2. Again, n is the integral number having values 0, plus minus 1, plus minus 2 and so on. If we explain the occurrence of interference with the help of a diagram, we can see that before striking to the slits, we have the light waves of plane wavefront. There comes a barrier which has two openings. These two openings works as a slit, and these two openings also works as two independent sources. The light waves obtain these two independent sources works as a coherent source, gives the coherent beam of light. We see that the light beams obtained these two independent sources are directly superimposed over each other, and the observed pattern is shown on the rightmost part of the diagram. The light part is the location where the constructive interference occurs, and the dark portion indicates the location where the destructive interference occurs. And when these two patterns are collectively placed at one place, then the interference pattern is created. The next topic for the discussion is diffraction of light. Diffraction is the slight bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of light to the size of the opening. If the opening is much larger than the light wavelength, the light bending will be almost unnoticeable. However, if the two are closer in size or equal, the amount of bending is considerable and easily seen with the naked eye, as it is shown in the diagram given below. In the first portion, we see that the opening is much larger, therefore, the observed pattern of diffraction is quite unnoticeable. Whereas, in second case, the opening is slightly small, then the observed pattern is easily noticeable. Now, the question arises, what is the difference between the diffraction and interference? So, there are two main differences as per their different definitions. Interference is the occurrence of the concordance of two monochromatic coherent rays which result in the maximum increasing or weakening of the intensity of light. Whereas diffraction is the appearance of wave shifting from the initial direction of stretching in its hitting into the obstacle. Second is the requirement and condition. In order interference to happen, the wave source should be coherent or monochromatic. In case of diffraction, the wave should be of similar size to an obstacle in a barrier. These are the two basic differences in interference and diffraction. Hope you had enjoyed the lecture. Thank you.